Hi everybody, so I just wanted to go through some videos of how to draw chair conformations. So with that, I'm going to go ahead and draw the chairs. If you're in my class, we talked about the idea that you start with these parallel lines, and there's always two chairs in equilibrium with each other, and you just change the direction of those parallel lines if you want to flip between the two. So now I'm going to add in the tips of the chair. So the first tip here is going to go opposite direction. So the lines were going up, so that meant the tip went down. And then when the lines are going down, the tip goes up. So this is how you draw both of those chairs. This one's a little bit too far to the right, so I'm going to scoot it back over. All right, let's scoot. There we go. So let's draw those parallel lines again. So they need to be opposite directions. So like this. And then I can add in, nope, go back to that. There we go. Oh, we'll make it work. Okay, so here are the chairs, and I always number things. It helps me keep track of where stuff is, and I do advise doing that. Now, when I number these, I am not naming them. So because of the fact I'm not naming them, it doesn't matter how I number this, okay? If I wanted to give the IUPAC name, sure, yes, it absolutely matters how you number, but that's not what I'm doing. All I'm doing is drawing chairs, okay? So I'm just gonna number like so, because that's the way my brain works. And now, when I number the chair, for your first chair, it doesn't matter how you number it. Again, we're not naming this. You can do whatever you want, but you need to be consistent with the second chair. That's where it matters. So for the first chair, I always just look at those parallel lines we just drew, and those are always, the top line is my carbon 1 and 2. All right, and then I just go clockwise. So I'm consistent about being clockwise, and then I'm consistent on which carbons I'm numbering. All right, so now I'm set up to start doing the chair. And the phrase that I always think of when drawing chairs is wedges are going to be up, dashes are going to be down. And that's going to help me figure out axial and equatorial. So if we look at our first substituent here, we have a methyl group. It is on a dash. So with my phrase, that means that this should be in a downward position. Okay, so if I look at carbon 1 of my first chair, which is here, I have two positions. I have axial and I have my equatorial position. And since I just said that I need this methyl group to be in the down position, between these two, equatorial is up, whereas axial is down. So that means this methyl group needs to be axial, because that matches the direction that the wedge is telling for me to be in. All right, so that's the first substituent. The second substituent, I have an ethyl group here. I have two carbons coming off, so that's ethyl. So, and then I could have written methyl group here. We'll write a methyl group there just for fun. So carbon 2 of that first chair, my axial would be here, my equatorial would be in this direction. So I'm on a wedge, so that means that my wedge should be up. So therefore, this group should be up. And axial versus equatorial, well, axial is higher up, so that means the ethyl group goes here. All right. And then I have another substituent on 4. It is on a dash, so this should be down. All right. So if I look at 4, my axial position would be going in this direction. My equatorial would be going here. So if I want to be down, that means I need to be equatorial. And so that's my first chair. All right, I have, let's see, I have two substituents in the axial position and one in the equatorial. So my 2 in axial are going to be the methyl group and then my ethyl group here. And then the methyl group that is here is equatorial. Okay. So thinking about chair flips, that means I should draw a chair that has, in the flip, 2 equatorial and 1 axial. Okay. So when I draw this second chair, I ignore the chair that I just drew. I don't even pay it. I hope you just didn't slash yours out because we're going to need it. But I don't pay attention to this at all. I just go straight back to the structure that I started with, which is the cyclohexane here, right? Okay, and I do the same thing. I see that this first substituent is on a dash, so it should be in a downward position. So if I look at carbon 1 on the new chair, there's my axial, and then my equatorial is this way. And so it's easy to see here, equatorial is lower than axial, so that's my down position, and that's where the methyl group should be. Okay, so there's my, here, I'll get rid of that for a second. So there's my first substituent. 2, this would be my axial, and then here is my equatorial. Yeah. All right, so I should be up for the ethyl. So equatorial is where I want this group. So here we go. There we go. All right, and then my last substituent on 4 should be down. So this is axial, this would be equatorial, and so I would want that methyl group down. Actually, let me make this ethyl since that's what I did on the first problem, so I'm consistent, so ET, and then methyl group should be here. Okay, so we predicted, based off the first chair, that I should have 2 groups that are equatorial and 1 that's axial. So I see the methyl group here and the ethyl group there are equatorial, and then this methyl group is axial. Okay, that's great. That matches up, but I want to make sure I flip this correctly. And the thing to remember with that is your direction, which is up versus down, should not change, but your position should. And when we say position, we mean axial, equatorial. That is supposed to change. That's how you know that you have done the flip correctly. So let's look at this first substitution on 1. So here, this was down in the axial position. On the new chair, this was down in the equatorial. So we can see that direction did not change, but position did. So this is correctly flipped. If I go to the ethyl group, I'm starting as up axial, and then here I am up equatorial. So again, my direction stayed the same, which is good, and then my position changed. And then here I had an equatorial that was down for methyl, and here I have an axial that is down. So I know that I have correctly flipped this chair because I have followed this direction, or this saying, I guess you can whatever, I don't know, but the direction did not change, but position did. All right, so that's a really easy way to self-check yourself when drawing a chair.